Hey, seventh graders, happy Monday. It is May 11th. This is the first day of week 7, which is our second to last week of school and our last full week of academic classes. So congratulations on your hard work. I continue to be so impressed with your self-determination and your enthusiasm and your achievement. I'm excited to dive in today. We have been working on expressions and equations and ratios, proportional relationships. And we are going to switch gears and start working on some geometry work. So the work that will start today and continue through the whole week will change a lot every day, which is a little bit different than we have been experiencing in weeks 1 through 6. We've been working on really similar skills for the week, getting a little bit more complex or deeper every day. And this week, geometry is like a wide part of math, particularly in 7th grade. So we're going to start today with scale factors and proportional geometric relationships. We're also going to use scale drawings to find area and perimeter. So go ahead and set up your notes with these two topics. That way, by the end of the week, when you need to go and remind yourself about scale factor when you're taking that quiz, you can find your scale factor notes really quickly and easily. Please pause the video here if you need a little bit of extra time to finish that. Awesome. Let's start with just a review of scale factor. Scale factor is a factor or a number that you multiply to get from one figure to a scaled copy. So looking at these two parallelograms, they have different side lengths, but their angle measures are the same. It looks like the same shape, just expanded. So these are called scaled copies, and the scale factor is 4. The scale factor is 4. That's because you take each side and multiply it by 4 to get to the new figure. So side AD is 4, side WZ, we call that the corresponding side, we call that is times 4, 16. Same thing with side AB. Side AB corresponds to side WX. Side AB is 5, times 4 is 20. Okay, this is called a scale factor. This is called yes. One thing that I want you to know about scale factor is actually you can go in multiple directions. You can go in 2 directions. And when you change direction, you also change your scale factor. This is a lot like the constant of proportionality in your ratio table. Can be maybe 3 going one way, but if you turn around and go the other way, you're either dividing by 3 or multiplying by 1/3. Same thing here. When we're talking about scale factor, we're really talking about what number do you multiply? What number do you? Yes. So if I go from triangle 1 to triangle 2, I'm getting bigger. My scale factor is some number larger than 1. But if I change direction and say I go from triangle 2 to triangle 1, notice I'm getting smaller. Getting? Yes. So in that case, the scale factor is a fraction that's smaller than 1. So maybe this is times 2, and maybe this way is times 1/2. Okay. So keep that in mind when you're finding your scale factors. Let's do a quick check for understanding. Can you please find the scale factor from quadrilateral ABCD to quadrilateral A prime, B prime, C prime, D prime? All that means is let's start with this blue rectangle and then move to our green rectangle, finding the scale factor. "15 seconds left. Your answer is a number. Is your scale factor bigger than 1 or smaller than 1? If you were thinking it was smaller than 1, you are correct. Because I'm taking a larger rectangle and then getting a smaller rectangle, I'm going from blue to green, my scale factor is less than 1. It's a fraction less than 1. So the question is, what fraction is it? I have to know that side AD is 1, 2, 3, 4 units long. AD is 4 units long. A prime, D prime is only 1, 2 units long. So what factor could help me get from 4 to 2? You might be thinking, divide by 2. Is that a factor? No, division isn't a factor. I need to multiply. So what number could I multiply AD by? Could I multiply 4 by to get 2? 1/2, you got it. Same thing with side AB. It starts out as 1, 2, 3, 4, 5, 6 times 1/2 is 3. The scale factor from ABCD to ABCD prime is 1/2. Okay, let's do another one. Go ahead and try this one. Label this number 1 on your paper. Please read and complete on your own. You've got 60 seconds. Go. Think, is your scale factor greater than 1 or less than 1? Last 15 seconds. Awesome, let's come back together. I know that I'm going from A to B. That's because it says scale factor applied to figure A to produce figure B. So I actually set this up. You might not have done this strategy, and that's totally fine. I just want you to experiment with it. I used a ratio table, and I thought, okay, I want to go from A to B. So let me look at the corresponding sides. I know the top of A was 3, and the top of B was 9. Let me show you one more time. The top of A is 3, and the top of B is 9. These are called corresponding sides. These are called? Yes. And same thing, I did the left side also. So the left side of A is 6, and the left side of B is 18. This strategy worked well labeling it the way I did because the figures were in the same orientation. One wasn't turned around or flipped over or anything like that. And then I'm just looking for what factor could help me get from A to B, the length of the corresponding sides on A to B, and that was times 3 each time. So the scale factor is 3. Take a moment, jot down this strategy on your paper, please. You probably got a scale factor of 3 using some maybe some mental math or a different line of reasoning. Go ahead and put the ratio table here, and while you write, I'll explain why. I want you to write it down because in the next few problems, we're going to look at some unit conversions, and it is really hard to use mental math strategies on the next few questions. So I want you to have a little bit of practice with this ratio table before we get into those next questions. Awesome. Pause the video here if you didn't get a chance to finish writing that down. Alrighty, let's do the next section. So we just talked about scale factor. A slightly different concept is scale drawings. Please follow along with me as I read. We use scale drawings to show objects that are much larger or much smaller than our drawing. This is a drawing of a house. Is the house actually this size? No, a house is actually much larger than this drawing, but we can make a scale drawing that that reflects the actual size of our house just using a lot smaller of units. There is a proportional relationship between the drawing measurements and the actual or real life measurements. Okay, so here's a scale factor that 1 inch in my drawing represents 20 feet in real life. Imagine that for a moment. 1 inch in my drawing represents 20 feet in the real life house. Okay, this is a scale drawing. Awesome, let's do some practice. Here's guided practice question number 2. Go ahead and write a number 2 on your paper, and let's read. This scale drawing of a rectangular rug has dimensions 8 inches by 5 inches. Dimension just means the important measurements of the sides. So in a rectangle, that's the length and the width. The length of the longer side of the actual rug is 32 feet. What is the length of the shorter side of the actual rug? Okay, Great questions. Let's go ahead and solve this one together. I want to use a ratio table strategy, okay? Just gonna fix my Zoom, stay with me. All right, hopefully that's big enough for you to see. Okay. Okay, so I have this scale drawing of the rug. Let's go ahead and put that on our paper. So it's a little bit longer than it is wide, and it is 8 inches by 5 inches. It would be really cool if I had an inch ruler and I could actually draw 8 inches by 5 inches. I don't, and so I'm just going to sketch it, no problem. I know that the actual rug is a different size. The actual rug is not 8 by 5. The actual rug is a lot larger. So I'm going to go ahead and draw a picture that represents the actual rug. Although I know it's going to be way larger than my drawing, I do just want to get an idea and help me remember that I'm getting bigger, so my scale factor is larger, right? Okay. And what else do I know? It says the scale drawing of a rectangular rug. Oh, here we go. The longer side of the actual rug is 32 feet. The longer side of the actual rug is 32 feet. So I'm going to go ahead and label the longer side. This one's shorter, this one's longer. 32 feet. Do that with me, please. And I want to know what's the length of the shorter side of the actual rug. All right, so here's where I am. Okay, I'd like to set up a ratio table. And then I want to show you one other strategy that maybe your brain is already thinking about. But let's go ahead and set up a ratio table. And on one column, I want you to label that the drawing in inches. Drawing, and that's in inches. Then I have the actual rug, or the real life rug, and that is in feet. And the same thing I showed you with figure A and B, where we labeled top and left. I think top side and left side, I think that could actually be really helpful here in this ratio table. So in my first ratio, I'm going to write the long side. And then after that, I'm going to have the short side. And I don't have it yet, but I know I'm going to have 2 ratios in my table for each pair of corresponding sides. Okay, so let's go ahead and fill in measurements for the long side. I know in the drawing, my long side was 8 inches. And in my actual rug, my long side was 32 feet. Do you see the scale factor? Yes, the scale factor is times 4. Great thinking. How about the short side? I know in the drawing, the short side was 5 inches long, and I want to know what the actual length of that short side is. I'm going to use the same scale factor times 4, and I get 20 feet. Okay, I'm going to go ahead and label in my picture 20 feet. Now you can also just use the picture, and this works really well when I've got simple shapes like a rectangle, so feel free to use this strategy. If I can draw an arrow to corresponding sides and see that, yep, that's times 4, then I also know this one would need to be times 4. Okay, you just have to make sure your arrow goes to corresponding sides. So if it's the bottom here, then it's the bottom here, as long as the picture isn't turned around. All right, 20 feet is our answer. Great work, team. All right, I'm going to zoom out a little bit. There we go. Let's go ahead and enter our answer for question 2 in the Google form. Awesome. Here is guided practice question number 3. So we're moving ahead. We're still looking at scale drawings, but we're increasing our rigor just a little bit. Follow along. The figure shows a scale drawing of an office floor plan on graph paper. Have you ever seen a floor plan before? Floor plan is like if you were looking down on a picture of, in this case, an office, these dark lines here would be the walls. So the office is this shape, you're looking down on it like from the ceiling. And every box is 1 unit in this picture, okay? It says, what is the actual perimeter of the office? I'm gonna give you a couple of minutes to try that on your own. Let's say a minute and a half, we'll try for this question. All right, go ahead. Remember that the perimeter is the distance around a figure. It's important that you see the scale factor on that picture. Remember that 1 unit represents 3.5 feet in real life. Okay, there's our time. If you didn't quite finish, that's okay. Go ahead and just stick with me and you can update your paper as we go. All right, so here's my work, all of my thinking to find the perimeter. I got 119 feet as the perimeter of the actual office building. How did I do that? First thing I did is I found the perimeter in units simply from the picture. So I took every side length added together and I got a perimeter of 34 units. What that might have looked like if I were working from the computer screen is actually counting. I started with the top side here and I counted 1, 2, 3, 4, 5, 6, 7 boxes on this side and I kept counting all the way around. 2 here, 3 here, 5 here, 3 here, 1 here, 3 here, all the way around. And that's where I got this monster kind of formula or equation here. And that's a sum of 34. If you got close to this, but not quite, if you got anywhere between, I don't know, 32 and 35, something like that, is just a counting error probably, or an addition error. If you got something different, you might have also not counted all the sides. So you want to count every single side, even those short ones that are only 1 unit long, every side is counted, okay? Once I get the perimeter of 34 units, that's the perimeter of the scale drawing. However, it asks for the perimeter of the actual office. So I'm going to go ahead and convert my units in the scale drawing to feet in the actual office using my scale factor of 1 unit to 3.5 feet. This scale factor was given in the question. Please label that the scale factor. Please label that the scale factor. That was given as a little box in the question, kind of like a, you see that often on a map, right? Where maybe 1 centimeter equals 100 kilometers. Awesome. Then I just figured out what my perimeter was in units was 34, and that was equivalent to 119 feet. Pause here to update your paper if you need to. All right, go ahead and enter your answer for question 3 in the Google form. Awesome, team, we're ready to move on. I'm excited to talk about this next part. This is, I think, the most rigorous part of our lesson today. The scale factor for length, which is what we've been doing all lesson, and the scale factor for area are different, okay? Take a look at this picture. I'm gonna kind of walk you through it. So take a look at this rectangle. There's a length of 5 centimeters and a length of 2 centimeters. The area is 10 square centimeters. Do you agree? Yes, 5 times 2 is 10. If I enlarge the rectangle with a scale factor of 2, scale factor up, yes, I'm going to multiply the corresponding sides by 2. So instead of 5 centimeters, my base is 10 centimeters because 5 times 2 is 10. Instead of a height of 2 centimeters, my new height is 4 because 2 times 2 is 4. Take a look at the area. 10 times 4 is 40. What's the scale factor that gives me my, that takes me from my area of 10 to my area of 40? Yes, it's 4. Notice how the side lengths multiplied by a factor of 2, but the area multiplied by a factor of 4. Why do you think that is? We spent a few lessons in the regular school year talking about why this is true. Really, it comes down to both side lengths were increased by a factor of 2, and so that changes my area by a factor of 2 squared, or 4. If I have every side length increased by a factor of 3, that increases my area by a factor of 3 squared, which is 9. If I have a scale factor of 4, my area scale factor is 4 squared, or 16. Big thing that you need to remember is that the scale factor for length and area are different, okay? Why do you need to remember this? Let's talk about that. That's why we're here, right? You need to remember this because sometimes in a question, it says find the area of the actual or find the area in the scale drawing. And what I want you to remember is that since the scale factor for length and area are different, you should find the new lengths first and then find the area. I'm going to model that in question 4, and you are going to do it in your independent practice today. So pay attention to the order of these steps. Here we go. A scale drawing for a rectangular parking lot measures 6 by 8 centimeters, 6 and 8/10 centimeters by 12 and 3/10 centimeters. The scale is 1 centimeter to 5 meters. Find the area of the actual parking lot. Perfect. Love this question. Let's do it together. On your paper, go ahead and set up question 4, please. And let's draw a picture. It says it's a rectangular parking lot. It says that the shorter side is 6.8 centimeters, and the longer side is 12.3 centimeters. Okay, and we're going to be converting it into the actual parking lot. I don't know what the dimensions are yet, but let's set up a ratio table. In my drawing, in centimeters, and in my actual, in, let's see, it says right here 1 centimeter to 5 meters. So my actual is going to be in meters. The scale is given in the question, 1 centimeter to 5 meters. So I'm going to go ahead and put that in, 1 centimeter to 5 meters. Awesome. I'm going to hide my notes now. I want you to finish this on your own, find the new dimensions, and then find the area, okay? We'll come back together in just 30 seconds for those new dimensions. Last 10 seconds. Awesome, let's come back together. So I was able to figure out, using my ratio table, I was able to figure out that if 1 centimeter equals 5 meters, then 6.8 centimeters was equal to 34 meters. I just used the COP times 5, the scale factor times 5. Same thing with 12.3 became 61.5. Notice I'm not finding the area of the scale drawing. Instead, I'm finding the new lengths first. I'm finding the, yes. Once I have the new lengths, this is my actual parking lot dimensions, I'm gonna then find the area. So first step is new lengths, second step is area. Go ahead and write it with me. To find the area of a rectangle, I multiply base times height. My base was, or one of the dimensions was 34 and one was 61 and 5/10. When I multiply, I've done that ahead for you, so don't worry, 2,091 square meters. All right, 2,091 square meters. Pause here if your paper doesn't look like mine yet. Awesome, so your paper is updated. One final reminder, because of what we know about the scale factors changing from length to area, we find the new lengths first, and then we find area after, okay? Your question of the day is you're gonna use that information, that reminder I just gave you, to fill in the blank. Go ahead and you can pause the video here to see this sentence. This is the one you're gonna be filling in the blank for. All right, we're ready to move on. Today, you have an independent practice to complete. It is really well matched to our notes, so make sure you have your notes with you as you complete your independent practice today. You have a skill builder that should be really quick. It's just finding the area of a rectangle. And then tomorrow, I'll do some more, some different shapes, like area of a triangle in our skill builder. Office hours today are at 3:15. Go see Ms. Russell to get some help on your assignments, to make sure you've got your answers correct, all of that good stuff. And that's it for me. I'll see you guys back here tomorrow, week 7. Bye.